Hello students, today we will see theory part 12, chapter 8 organic chemistry some basic principle and techniques, in which we will cover NCERT section 8.8.4 and 8.8.5. So this is our disclaimer. Now once you have attended this lecture, you will be able to understand the different types of techniques used for the purification of organic compounds. Now we have already dealt with two of them, I would say. The rest are related to chromatography, and the second one is related to adsorption phenomena. Okay, so we will look onto each of them one by one. If I talk about the specific sections of the NCERT, then according to that, we will be covering NCERT section 8.8, which is method of purification of organic compounds. Then we will see 8.8.4, differential extraction. And the second one is the chromatography, which is 8.8.5. Let us begin with the differential extraction. Now, the purpose of the differential extraction is to separate an organic compound which are present in aqueous medium. Okay, we have already dealt with one of the method which was used to separate the aqueous medium. Remember about that. Now this is the second one. What is the principle that is used here? So it is based upon the difference in solubility of your organic compound. Means the organic compound will be dissolved better in the one solvent as compared to the other impurities. Okay, so suppose you have I would say two parts of the product. So one part is more soluble in the solvent and the other part is less soluble in the solvent, and that is the difference part which helps us to separate the organic compound. Now about the solvent requirement. So the organic solvent which we are choosing, it must be one in which the organic compound is highly soluble. Okay, so we are trying to keep the solvent such that the solubility of organic compound, our target organic compound, is higher. The second thing is that it should be immiscible with water. Why? So that two different layers of the product can be formed, right? So basically what we are doing, we are using water in this whole process, but after the reaction, or I would not say after the reaction, after the physical change, you will see that the water is separated in a different strip, and the organic compound along with the solvent is separated in a different strip, and it is all happening due to the immiscibility of the solvent in water. Means the solvent is not soluble in water. Now moving on further, let us move on to the process. So here are two diagrams, before extraction and after extraction. We will try to understand both of them. Now if you see here, the image is providing a setup, and we are seeing an apparatus in which that setup is being built up. Now what you do, you take aqueous medium containing the organic compound and you shake it with the suitable organic solvent. Okay, so we have already seen what are the requirements for the solvent. You can see it in the diagram as well, that we have our organic compound which is present in the aqueous form, or you can say it is dissolved in water, and the top of that there is another layer of the solvent. Okay, you keep both of them and then you shake the bottle. After that, you know it very well that the solubility of the organic compound is very high in the solvent, so it will dissolve in the solvent layer. So this is the important part. Again I am repeating it. First you took the organic compound in the aqueous form, you place another strip of a suitable solvent which has a higher solubility for the organic compound. Now you shake this apparatus. What will happen? The organic compound from the water will be dissolved into the solvent. Now after that, you will observe two immiscible layers which are formed in the separatory funnel. So this is known as separatory funnel. And why two different immiscible layers are formed? Because remember, we took a solvent which is not soluble in water, so it will form a different strip and it will be above the aqueous layer. Now what you can do, you can see that we have a clock here. You will open this clock and drop by drop you will collect different layers from the outlet. So this is the first way. Okay, so what you do, again I am repeating the whole process. It's very simple. You must have seen this process in your organic labs also. So first you are taking your organic compound. Your organic compound is present in a aqueous phase. Now you take a solvent and you pour the solvent above this aqueous solution of the organic compound. Then you mix it well. After the mixture, the organic compound will be now soluble in the solvent rather than the water because of its higher solubility in the given solvent. And due to immiscibility of water in the solvent, the water will form a different layer along with the impurities and your organic compound will be present in the solvent strap. Then after you can just open the clock, take out the water, and then after you can take out your organic compound along with the solvent. Now the next method that we are going to see is chromatography, which is a crucial technique in organic chemistry. To understand this, you must remember that this chromatography is totally based upon two phases. Okay, so you will see two phases. First is the stationary phase. So of course, as the name is saying, it is a fixed phase and it can be a solid or a liquid onto which you will apply the mixture, the organic mixture that you are getting after the reaction. You will apply the mixture on the stationary phase. Then after, you have a mobile phase. Now what is this mobile phase? So it is of course a moving phase and it passes slowly over the stationary phase. So think it in a way, suppose water is flowing. Okay, so the below portion, the bed of the water body is your stationary phase, and the water which is flowing above this river bed is your mobile phase. So in that same way you will do the process of chromatography. Now why it is used? The first one is for purifying the compounds and the second one is for testing the purity of compound. Okay, so you can use it for either of them. If it is already purified, then you can test the purity, that how much level of purity is obtained. And if you are separating the organic compound from the impurities, then you can use it to purify it as well. Now the classification of chromatography is done broadly into two types. It is based upon the mechanism of chromatography. The first one is adsorption chromatography and another category is partition chromatography. Now we will learn about both of them one by one. So it's very easy to understand this chromatography process. Starting with the adsorption chromatography. So the principle behind this adsorption chromatography is that your compound is separated based on their varied adsorption to an adsorbent. It is important because it allows us to separate complex mixture into individual components. What are the common absorbents that are used in this process? So we often use this silica gel or alumina as an adsorbent. And your common adsorbent will act as a stationary phase here. Remember, we talked about a stationary phase and mobile phase. Stationary phase is one which is fixed. So here the adsorbent that you are taking is either silica gel or alumina, that will act as a stationary phase. Then what is the separation process? So similar to the flowing of water over the river bed, your mobile phase will flow over the stationary phase. Now what is your mobile phase? Often we take solvent as the mobile phase. Upon this movement of mobile phase onto the stationary phase, you will see that as a result of this flowing, the components of the mixtures travel at different distances, and due to that you will be able to separate them. Now further, your adsorption chromatography can also be classified into two types. The first one is column chromatography and the second one is thin layer chromatography. Okay, now what you should remember till now, the first thing you should remember is that your chromatography is based upon two phases, which is stationary phase and your mobile phase. What happens in the whole process? You flow your mobile phase over the stationary phase, right? So this is the basic method. Now first we talked about adsorption phase. Here we take adsorbent as the stationary phase, which is basically silica gel or alumina. Then in the mobile phase we have the solvent. So we'll talk about the first one, which is column chromatography. What is this column chromatography? So here is a setup. So you can see three columns. Now these three columns are defining three different stages. Let us look at them one by one. First of all, what you do, you take a glass tube fitted with a stopcock. So at the bottom of the diagram, you can see that you have a knob like thing. So it is representing the stopcock. Why it is there? So it is basically there to control the flow of the liquids that are present above it. Then after, next comes your packing of the column. How do you pack it? First of all, you packed it with the adsorbent. So the below phase you are seeing, the yellow phase here, in the first tube. So this is your stationary phase or your adsorbent. So here we are using silica gel as the adsorbent and it will act as a stationary phase. Then after, the second important thing that you do is placing a glass wool. Okay, so you can think it of as a cotton. So you place it above the stopcock. Why? So to control the flow. Again, this thing is again there to control the flow of the organic compounds and the solvents. So if you don't keep it there, as soon as you open the stopcock, the whole liquid will flow down. So it is a kind of valve present there. Then after, the mixture to be separated is added on the top of the packed column. You can see a brown layer. So it can, suppose it is containing three different type of components A, B and C. So we are placing that mixture above the silica gel. Okay. Then after we have the solvent, which is present in blue color. So these are the three parts. So next what we do, we put the suitable solvent which is poured upon this mixture. What will this solvent do? Remember, I told you the solvent will act as a mobile phase. So this is the phase which will move. Okay. Whereas your silica part will be stationary at their place. Let us do the process. How we will separate it? So this was our setup. The first step is that you allow the solvent to flow down the top. Okay, so it will start to flow from the top here. Now this solvent that you are seeing, it will carry the compound down the column at different rates depending on their affinity for the stationary phase and solubility in the eluent. Okay, so basically two factors are there. The first is the solubility in the eluent, means the solvent you are using, how much is it able to dissolve this whole mixture. And the second thing is the stationary phase. The affinity to the stationary phase means how much your A, B and C are individually attracted to your stationary phase. On the basis of that, you will separate the given compound. Now, after you have done this thing, see we have the second diagram here in the middle. So the solvent flows and slowly along with the solvent, the mixture will flow through the stationary phase. Then after, in the last part, you can see that your mixture has separated into distinct bands A, B and C. So these were the three components. Now, the compound that interacts more will move slower. So basically, it is totally based upon the interaction. How much your organic compound present in the mixture is attracted towards your stationary phase and how much it is binded to the solvent. If it is binded stronger to the solvent, then it will move slower, move faster. And if it is binding stronger to the stationary phase, then it will move slower. Now, if you look upon the A, the band number A, so it interacts strongly, and that is the reason it is moving slowly and it is present on the top. Then after, rest of the one, which is B and C, they are moving faster in compared to A. So they are moving faster, so they are forming a band at a position lower than that of A. And the C one, which is interacting least with your stationary phase, so that has moved a lot. Now what you can do, you can slowly open this stopcock. First the C will come out, you can separate the C, then close the stopcock. Then after, the B will come out, separate it in another funnel, and then the A will come out. So in this way you can collect individual compounds. Now moving on to the next one, we have the thin layer chromatography. So this is the second type of adsorption chromatography, and you use it for identification and analysis of mixtures components. As I told you, so this is another type of adsorption chromatography. So this will be also based upon the adsorption phenomena. In short, we call thin layer chromatography as TLC. So here is the setup for you. What you can see in the setup, the first one is jar. Okay, so we have a jar. So this is used as a chamber so that you can develop the TLC plate. It is basically a controlled environment where the solvent can move up the plate by capillary action. Next we have the TLC plate, or the thin layer chromatography plate. So it's a glass plate coated with an adsorbent. Now this adsorbent is the stationary phase where the separation of components occurs. Then after, we have the solvent. Now this solvent is placed at the bottom of the reaction. You can see a blue color liquid present at the bottom of this jar. So it carries the sample component with it, allowing them to separate based on their interaction with the adsorbent. So now again, the solvent is acting here as a mobile phase, and your TLC plate or your adsorbent coated on glass plate is acted as your stationary phase. Next, we have a sample dot. So what is this sample dot? Basically, you place the mixture as a spot on this plate, glass plate, right? You can see here a yellow dot here, which is present here, and this is your mixture. Next, we have a baseline. So you take a pencil above 2 cm, you draw on the TLC plate with the help of scale a line. So that is acting as a baseline. So this will act as your reference point and help you to measure how far the component has traveled during the whole process. Now, let us try to understand the procedure of this thin layer chromatography. So if you just remember this diagram, so the first part that you will do is you will place a glass plate placed in a closed jar containing a suitable eluent. So eluent is basically referred to as your solvent. Again, as I told you, the solvent will act as the mobile phase. Then next, we will spot small quantity of the mixture solution onto the baseline of the glass plate. Next, after spotting the small quantity of mixture on the TLC plate, put TLC plate in a closed jar that you have taken containing the appropriate solvent. Right after that, you will see that your solvent is rising up. Of course, it is your mobile phase, so it will flow over the stationary phase. Why it is happening? It is happening due to the capillary action. Now, mixture separate based on the adsorption of through the layer. So basically, your solvent will take up the organic compound present as dot. Then due to capillary action, it will move upward. Now, your mixture will contain different components, and different components will have different affinity towards your stationary phase. If it has a stronger affinity, it will not move further away from the spot. But if it is having a weaker affinity towards the stationary phase, then it will move further away from the stationary spot. So basically, it is again based upon the interaction of your mixtures component with the stationary phase. Now take the plate out of the jar, and here timing is important to ensure optimal separation. Okay, so as soon as you see a separation in different spots, just stop there. Next, immediately mark the position where the solvent stopped rising. This mark is crucial for calculating the RF value, which helps us in identifying the components. Finally, we detect the spots by locating the separated spots on the plate. This step allows us to analyze the result and determine the composition of mixture. So if you are getting only one spot, it means that your organic compound is present in pure form. But if suppose upon the movement of the solvent, you are seeing different spots on the TLC paper, that means your given liquid is containing a mixture of organic compounds. Okay, moving on further, we talked something about the RF value. Okay, so the what is RF value? So it is a key concept in chromatography that help us to understand how different components in a mixture move at different rates. So it's a measure of how far a compound travel relative to the solvent front. The RF value quantifies the relative adsorption and movement of each component. And here is the formula for that. To find the RF value, the RF value is equals to the distance moved up by the substance from the baseline x upon distance moved by the solvent from baseline, that is y. Okay, suppose x is the distance moved by the substance and y is the distance moved by the solvent. You divide x by y, you will get your RF value. So something this type of diagram that you will get after the process is completed. Okay, so you will see that your compound was originally here, but as your solvent moves upwards, it will take the compound along with it, and suppose it stops here. So this is the second stop. Okay, and the solvent is moving further. The solvent will move further and it will stop here. Right. So these are the two things. So 2.1 is the distance moved by the compound and 2.8 is the distance moved by the solvent. So how you will calculate RF value? So it will be 2.1 by 2.8. Now, if you calculate this, you will get it as 0.75 centimeter. So this is your retardation factor. Okay, the previous diagram that you saw, in that you were able to see only one spot. So the organic compound was pure. So we were trying to calculate the RF value for the organic compound itself. So that is the reason we got one spot. But if you take a mixture, you will get different spots. Moving on to the next one, we have thin layer chromatography. It is used for the detection of separated components, okay, so which are known as spots. How do we do it? So if the compound is colored compound, so suppose you got different spots and those compounds are colored. In that case, your spots are visibly directly due to the inherent color. But there can be a case you will notice no spots on the TLC paper. For that case, you need special techniques for detection. So we will start using UV light in that case. So if a compound is fluorescence under ultraviolet color, we can detect it by placing the TLC plate under a UV lamp. So this is a common method for visualizing colorless spots. Another method which is used for detecting colorless compound is using iodine vapor. So by placing the TLC plate in a covered jar with iodine crystals, compound that absorb iodine will appear as brown spots. So this is also a simple yet effective way to make invisible spots visible. So these are the two ways you can identify invisible spots or for the compounds which do not show inherent color. Now, once you got this adsorption chromatography, next we will move on to partition chromatography. So it is based upon the continuous differential partitioning of the components of a mixture between stationary and mobile phase. This means that as the mixture moves through the system, different components will separate based on their affinity for the stationary phase and the mobile phase. So the type of chromatography which is used in partition chromatography is the paper chromatography. Okay, what it involves? The first thing is stationary phase, of course. So it is a special quality paper known as chromatography paper which is used. In that stationary phase, water molecules are trapped within the paper pores, and that will act as a stop or as the stationary phase. Now next we have the mobile phase, which is also known as eluent. So in that case, we take suitable solvent in which the paper strip is suspended, and this will act as the mobile phase as usual. So rather than taking silica gel or alumina, you simply take a TLC paper. So basically TLC paper have water pores in between the paper, and that acts as a stationary phase. Next, paper chromatography is a type of partition chromatography. We have seen this, and this is the setup for it. You have a cardboard and you have suspended your chromatography paper along with the cardboard. Then we have a jar, and similar to that of your previous, which is TLC, you also have a spot here. Then you have a baseline and a solvent placed in the bottom of this jar. So if I talk about the setup, the first is the jar, which acts as a chamber for the whole procedure, and it provides a controlled environment where the chromatography process can occur without external interference. Means to avoid the I would say the application of air. Okay, so to avoid that, we are doing it in a closed container. Then we have chromatography paper. So it's a special type of paper in which the water is trapped and it acts as the stationary phase. Next we have the solvent, which is placed at the bottom of the jar. It serves as the mobile phase and moving up the paper and carrying the different component of the mixture with it. After that, we have a sample spot, which is where your mixture is applied, which is to be separated. It is a small dot on the paper, and as the solvent moves, it will carry the components at different rates. Then we also have a baseline, which is a pencil line drawn near the bottom of the paper. This line marks the sample where the sample is initially spotted. It helps us to track the movement of the components. Lastly, we have a cardboard. So it is used to support the chromatography paper from the top of the jar. This ensures that the paper stays upright and stable during the whole process. Now, let us move on to the procedure. So what is the procedure? Starting with the first point, the strip of the chromatography paper is spotted with the solution of the mixture at its base. So this is the first point. The second one is you suspend the paper strip in the mobile phase, which is the solvent, inside a chamber. Now this step is important because the solvent will travel up the paper carrying the mixture with it. As the solvent rises up the paper by capillary action, it moves over the initial spot of the mixture. This movement is key because it allows the component of the mixture to start separating based on their interaction with the paper and the solvent. Then, as this process continues, different spots are observed on the chromatography paper. So this differential sticking is which allows us to separate and identify the components. It is happening because the component prefer to be either in the water already on the paper or in the moving solvent. So this preference is based on their chemical properties such as polarity. So if your compound is more polar, it will get stick to the chromatography paper as it is containing water along with it, and if it is less polar, it will move along with the non-polar solvent. Now as the solvent continues to rise, it passes through the spot containing the mixture. Now what is detection of components? The last one, similar to that, you can see a colored spot. So most of the compound has an inherent color, and due to that color you are able to see different spots telling you that the mixture is containing different components. If it is a colorless compound, in that case you have to observe it under ultraviolet rays. Okay, because some of them can show a fluorescence, so they can be observed under ultraviolet light. So let us summarize today's discussion. So first, we started with differential extraction. It is based upon the affinity towards the solvent. Okay, So you separate an organic compound from an aqueous medium here. Then we started with the chromatography. About chromatography, we use it for purifying compounds and to test the purity of the compound as well. So this is the second implication. Then your chromatography is classified into two types. The first one is adsorption chromatography. The second one is partition chromatography. The adsorption chromatography separates compound based on their varied adsorption to an adsorbent. So we use a specific adsorbent like silica gel or alumina. Whereas in the case of partition chromatography, use a chromatography paper. Now the adsorption chromatography also are of two types. The first one is column chromatography, where you use a fractionating column, and in that fractionating column you place three different layers. The first layer is of stationary phase, the second is of the mixture, the third is of the solvent. You open the stop clock, then the solvent moves through the organic mixture, and upon further interaction with the stationary phase, it forms different layers depending upon the number of components the mixture has. You also have a cotton wool placed before the stop cock so that you can control the flow of the liquid. Then you have the second type of adsorption chromatography, which is thin layer chromatography, where you use a glass plate coated with silica gel, and based on the interaction of your components of the mixture, you get different spots on this silica plate. The last one, which is a part of partition chromatography, known as paper chromatography. So why it is used? It is used on the basis of the chromatography paper. Okay, so instead of using a stationary phase as silica gel, you simply used a water containing paper, means the pores of the paper is containing water, and based on the continuous differential partitioning of the components of a mixture between stationary and mobile phase, you separate them. So if an organic compound is more polar, it will be adsorbed onto the chromatography paper in an efficient manner, and if it is not, then it will move along with the solvent. So this was all for today's lecture. Thank you for joining the session. I hope you enjoyed it.